Okay, I'm gonna talk through this review for you guys. So the first thing asked me to draw each of these following things, and just one of them. And as far as make sure to label the triangle appropriately, what I mean is put marks on there so I can see what you mean. So for example, for number one, the midsegment, a midsegment is connecting the midpoints of two sides of a triangle. So I need to actually show that I know what a midpoint is. We're not going to get out a ruler for this. We're just going to use our best judgment to find the midpoints. So for example, if I wanted to find the midpoint of like this side right here, I might say it's about there, and that's a midpoint. And how I could show that is by saying the two segments that it bisects or that it's the middle of are congruent. I need to pick one of the other sides too, so maybe I'll pick this one up here. I'd say the middle is about here. Again, I can show this by showing the two pieces are congruent. And then when I connect that, that's a midsegment, just a single one. Next one, angle bisector. So we're talking about the angles. We're trying to bisect it. The word bisect means we're going to split into two equal pieces or cut in half, might be how you think of it. So again, I just need to pick an angle and I need to draw a line that makes it look like I cut that in half, that angle. So this time I'll just pick the top angle, and I'm trying to separate this exactly so the two parts look equal. So I kind of started my line there. I'm going to go ahead and draw in as straight a line as I can. But then this piece is equal to this piece. So if this was 30 degrees, that'd be 30 degrees, something like that. A perpendicular bisector, this is kind of one of the ones that we seem to struggle with, but remember there's two parts here, so you have to think about perpendicular means it forms a right angle, bisect means it cuts that in half. So I usually start with the bisecting part. That means I'm going to be going through the midpoint of a side. So again, I can pick any of the sides. I'm just going to pick this bottom one, and I've got to find the midpoint. So again, I'd say that's about the middle of that side. Now I have to draw a line that is perpendicular to that side, so it needs to make a right angle. For me then, a lot of us try to go from the vertex. You can't go from the vertex. I'm just going to look as close as I can to making a straight up and down line here that makes a right angle with that side. Okay? It's not going to go through the vertex. Could it? Sure, but it's not necessarily going to. What's different about a perpendicular bisector and a median, that same thing's going to happen with a median. I'm going to the midpoint of a side, so I'm going to go ahead and draw in the same thing. But now I am going from the vertex. So it's a segment from the vertex to the midpoint of the opposite side. Lastly, an altitude. An altitude is just the right angle part. So I'm going from the vertex of one of the vertices straight to the opposite side to make a right angle. So I have to be able to say, okay, I'm going from this vertex, I need a right angle with this opposite side. Okay, so those are the basics for those 5 things that we talked about in this chapter. Then we have to be able to decide if we drew 3 of these in each triangle. So if I drew in 3 mid-segments, I could do some stuff with that. 3 angle bisectors, where do they all meet? If I drew in 3 perpendicular bisectors, where do they meet? Medians, altitude, same thing. So that's where these words come into play. So this part was interesting to me. Match the point of concurrency. Some of us didn't know what that meant. The point of concurrency is the point where these things meet. So examples of points of concurrency are circumcenter, incenter, centroid, and orthocenter. So you need to have these memorized. You need to know that circumcenter is where the perpendicular bisectors meet. The incenter is where the angle bisectors meet. The centroid is where the medians meet. And the orthocenter is where the altitudes meet. If you don't have those memorized, then the next part's really, really hard. So definitely need to have that memorized. Make yourself some flashcards. So next I'm sketching the following point of concurrency in the triangle. And again, it asks me, be sure to label congruent segments, congruent angles, and right angles. So in other words, what they're really asking when they're asking me to make the circumcenter is to make the 3 perpendicular bisectors, one to each side, and show that they meet at the circumcenter. So I'm going to make that same perpendicular bisector I made up before. I know these two parts are congruent. I'm making a right angle. And then I need to do that from every side. So I kind of like to turn my paper. That seems to make more sense to me, so that I can see a little better where the middle is and being able to make a right angle. So I'd say the middle of this side is about here. And then again, I'm making a line that's perpendicular, so it needs to form a right angle. So maybe something like that is pretty close. I'm going to turn my paper back the other way and do the same thing for this side. So I'd say the middle is maybe here, about the midpoint of that side. And then again, I'm trying to make a right angle. And you can see that if I try to be careful as I'm doing this, and again, we could use a ruler and a protractor and we could make this really exact, but if I'm just sketching it, because it says sketch, I can go ahead and just use kind of my eyes to find the middle and do the best job I can to make a right angle. But then I can see that, yes, this point right here where all the perpendicular bisectors meet is the circumcenter. I'm going to do the same thing for the incenter. For the incenter, we know we have to make angle bisectors. So I have to try to separate the angles so that I have two congruent angles. So there's my first one. Again, I'm going to turn my paper. It just makes things easier for me. And again, I'm going to try to split this as best I can in half. And then same for this third one. Okay, and you can see that I'm marking it along the way to show these angles are congruent, these angles are congruent, these angles are congruent, showing that they actually are angle bisectors and they all meet at the incenter right here. Next one is the centroid. The centroid goes with the medians, like we said up above, so I've got to, again, find the midpoints of the sides. This time I'm connecting the opposite vertex. So there's my first median. Again, it's helpful to turn my paper. Here's the middle of this side, connect it to the opposite vertex. And then lastly, middle's about there, connected to the opposite vertex. So that point is where they all meet, is that point of concurrency. Again, remember that's what we're trying to find, is the centroid. Orthocenter, we need to make right angles, make altitudes here. So again, I'm going through the vertex, and I can go outside the triangle too if I'd like. And I'm making a right angle with the opposite side. So through the vertex, through the opposite side, making a right angle. Again, turn my paper, do the same thing here. So there's another altitude. And one more altitude, and we should be pretty close. And so, we made our orthocenter right there. So not only do you need to be able to construct them, then you need to be able to do something with them after you know that information. So for example, in number 14, they tell us, find the value of x that makes n the incenter. So if we know n is the incenter right here, then we know we have angle bisectors. So we know that BN is an angle bisector, CN, AN. But the important part to know then is when I have all the angle bisectors meet at the incenter, then it's an equal distance to each side from there. So in other words, NL, KN, and NM are all the same. Which would be helpful, except for that NM is 4x. So we just know that each of these are 4x as well. And so the part you need to notice that's going to be really, really helpful is that I have right triangles then. So this right triangle right here, we'll see if it shows up on the screen, is the one I'm trying to use. Not super easy to tell. Let's see if I can use a different color. I want to use this one right here. So I'll draw it out here. LCN. I know this side's 48. I know this is a right angle. I know this side's 52. I know this side's 4x. So I can do the Pythagorean theorem since it's a right triangle to find x. So I know I want to do 4x squared plus 48 squared equals 52 squared. 4x squared, be careful there, you need to take 4x times 4x, which will be 16x squared. 48 squared is 2,304. 52 squared is 2,704. And I'm going to keep solving from here. So subtract the 2,304. Got 16x squared equals 400. Divide by 16. Should know that, but I didn't. 25. And then take the square root. Since we know that we're talking about a distance, we know positive 5 is going to be the only answer here. So if you look at 15, 15 is just practice to do the same thing again. I know that the distance from the in-center to a side is 3x, so that's 3x, this is 3x, this is 3x, so it's the exact same idea. We're going to do 3x squared plus 45 squared equals 51 squared. So 3x squared is 3x times 3x, so 9x squared. 45 squared is 2025. 51 squared is 2601. Subtract. Take 576, divide by the 9. And x squared equals 64, so when I take the square again, I can just only have the positive value, so x equals 8, since we're talking about a distance. So those two are actually harder than the next one. The next one still is talking about the in-center, so still the same information where I know if G is the in-center of ACE and they want me to find BG, BG, GF, and GD are all supposed to be the same. So if GF is 16, then I definitely know BG is 16, so is GD, which is 16 for the answer. And one more with the in-center. Point P is the in-center of HKM, find JP. So this one's kind of the same idea as 14 and 15 as far as I don't know any of these, but they're the things that I know are congruent. But I do have a right triangle again down here in the bottom right corner. And this right triangle is really important because that I don't know. I'm going to call it x from P to N. So again, I can do x squared plus 24 squared equals 25 squared. And if I solve that, then I should be able to get any of these, whether I'm asking for JP, PN, or PL, but I know they're all the same. So 576, 625. If I subtract that over, I get 49. And the square root of 49 is 7. And so since I know PN is 7, I know JP is 7, and so is PL. Okay, so lots of work with in-centers. So big thing to take away is their Pythagorean theorem is pretty helpful since I've got the right triangles. Okay, if you flip over to the back, then we have some work with centroids. And just a little bit. G is the centroid of ABC, we say. AD is 8, that's marked on there for me. AG is 10, that's marked on there for me. CD is 18, and it was hard for them to draw it on here. I'm going to try my best to say CD is 18. So I got to remember we're talking about that whole thing. Find the lengths of the segments. So there's lots of things to find here. We have to remember what a centroid is. First off, a centroid is where the medians meet, so that's a big deal. And then I have to remember the property that goes along with that is that from the vertex to the centroid is twice as much as from the centroid to the opposite side. So for example, for this first one, BD, that we're trying to find, since I know this is a median, I know that it went to the midpoint, so AD and BD have to be the same, and this has to be 8. For 19, they want AB, so we want the whole side now. So 8 plus 8 is 16. EG, so here's where we're getting into the relationship between the, or like the distance from the vertex to the centroid, centroid to the opposite side. So When they ask me for EG, I know that's half as much as AG because it's double the distance here. So GE must be 5, and I've kind of made it so it's hard to write that in here. Put our 18 on the outside more. Then AE, so now we want the whole thing, A all the way to E. 10 plus 5 is 15. CG and DG, we're breaking apart this one that we knew was 18. So since we knew the whole thing was 18, we knew this was double this, we actually need to divide the 18 by 3 because there's 3 congruent pieces in there. So we know the smaller one, DG, is 6, and since we know this will be double that, we know this one will be 12 to add up to the 18. So to fill in our blanks over here, this is 12, this is 6. Next section talks about the circumcenter, so now I need to know that G is a circumcenter, so we're talking about perpendicular bisectors in this triangle. They tell me D, E, and F are the midpoints of the sides, which makes sense because if we have a perpendicular bisector, we do know that this is congruent to this, this is congruent to this, and this is congruent to this. They want me to find all of the indicated things here too. So for AG, this piece right here, that's what's special about having the circumcenter. From the circumcenter to each vertex is the same distance. So the things that I am highlighting right now in pink, those should all be the same. Okay. So since this one's 25, this one's 25, so is BG. So AG is 25. Next thing they asked me for is BD, and you saw I marked things around here after they told me they were the midpoints, but I should have known that anyway by perpendicular bisectors. Either way, BD is 20. CF is 24, because it's going to be the same as AF. BG, we marked a while ago saying, yes, from the circumcenter to each vertex is the same, so that's got to be 25. CE is 15. Again, because I've got the bisector. And AC is this whole side down here, so 24 plus 24 is 48. In the next section, is it possible to construct a triangle with the given side lengths? If not, explain why not. Remember that any two side lengths, their sum has to be greater than the third side. So any way I put it, if I add 2 together, it's got to be greater than the third. So for number 30, if I think through that, 8 plus 9 is greater than 15. Like, that works. 17 is greater than 15. If I do 9 plus 15, it's definitely greater than 8. That works. And if I do 8 plus 15, definitely greater than 9. So since all 3 of these, any way I add them, the 2 sides, it's greater than the third, I know this is definitely a yes. But when I look at number 31, the very first thing I think of is I'm going to do 4 plus 7, and that's a problem because it's not greater than the third side. 11's not greater than 13. So if the sum of 2 sides isn't greater than the third, then it's not a triangle. So it says to explain why not. So I'm going to say no, because the sum of 4 and 11 is not greater than 13, so it can't form a triangle, or these sides can't form a triangle. So I don't even have to try the other ways. As long as there's one that doesn't work, I mean, that's it. Like, it can't, it's not going to connect together. So for 32 and 33, I'm kind of taking that into consideration then, that if I know 2 of the sides, if I know they're 5 inches and 6 inches, then I know that my lower bound has got to be that I can't have 1 inch, because 1 plus 5 would be equal to 6 and not greater than 6. So I got to have stuff that's greater than 1. So I could have any value bigger than 1. I could have 1.1, 1.0001, just above 1. And at the same time, if I take 5 plus 6 is 11, I don't want to have 11 because, again, that'd be equal to 5 plus 6, and I want it to be 5 plus 6 to be greater than, so I need something like 10.999, so I need things less than 11. So my idea for possibilities has got to be x has got to be greater than 1 and less than 11. So I can write it like that, or you may have seen it like this, or in words like we're saying x has to be between 1 and 11. Same thing for the next one then for 14 feet and 21 feet. So to get the lower bound, subtract. To get the upper bound, add. And yeah, this one I didn't add in my, better put inches on there. So 7 feet, between 7 feet and 35 feet is where I want my values. 34 and 35, we're listing things in order from smallest to biggest. Remember that, one, I can just look at the angles and see in number 34 which one's the smallest. So 50 degrees is the smallest, so angle A, the medium angle is angle B, the largest angle is angle C. Then how I'm deciding the sides is I'm going across from each of those. So angle A is the smallest, so across from it, opposite of it, is side BC, so that's got to be the smallest side. Angle B is the medium one, so opposite of it is side AC, that's got to be the medium side length. And then the largest angle is across from the largest side, AB. So same thing over here, except for they give me the sides first, so I'm actually going to list the sides first because that helps me to know the smallest side is EF, the middle side is FD, and the biggest side is ED down here. Then I can go with the angles across from them. So across from EF, angle D, across from FD is angle E, and sorry, across from with this I know some of us struggle with, so I've got to look at EF and be like, okay, the angle over here that doesn't include that side to make up the angle, so across from it. 19's across from E. 30 is across from F. Next ones have to do with the hinge theorem, these last two problems. So we want you to complete with less than, greater than, or equal to. So if I look at these two triangles, I have two congruent sides. So the hinge theorem says that if I have two sets of congruent sides, then I can look at the angle in between and it should tell me something about the side across from it. So since I know the angle in between the two congruent sides, and this one is 68, I can say something about PR compared to across from the 72 down here, VT. And since 68 has to do with PR and it's smaller than 72, PR has to be less than VT, just like 68 is less than 72. Same kind of thing for the next one. I can see these sides are congruent. I know these are congruent by the reflexive property, and I guess I just know these angles are congruent because the whole thing is an isosceles triangle. So this has to be congruent to this by the base angles theorem. As far as if you know that these two things kind of are congruent too, I guess. That one's kind of tough, but yeah. Fair enough. They should definitely be equal by the base angles theorem. Number 38, they want us to again use the hinge theorem. So I can see that 10 and 10 are congruent. I know these are congruent. So I must be trying to compare the 3x plus 8 with the 71. And if I look at the things across from them, that's going to tell me kind of how to compare it. So since 12 is less than 16, what's across from it, 3x plus 8, must be less than 71. And then I'm going to go ahead and solve that inequality. So first subtract 8, and then divide by 3. So x has to be less than 21. Last problem, same thing. I can see 7's congruent to 7, reflexive property right here. So this one's interesting, the angle's in between. So 94 is the angle in between here. That's what I'm going to compare to the x plus 11. But over here, I need to figure out that angle first so that I can compare the angle in between to this angle in between over here. So I'm going to have to do 105 plus 34, which is 139, subtract from 180. So 41 degrees is what I'm comparing over here. 41 degrees is clearly less than 94. So 5x minus 7's got to be less than x plus 11. And then solve from here. So subtract x. Add 7. Divide by 4. I don't get a whole number. I can either keep it as a fraction or a decimal is fine as well because it's 4 1/2.